Sounds good. So I think my screen everywhere. We're gonna do kind of similar model to what Dominic did before. If you want to do the sticky note type piece or the sheet, if you could tell yourself something, at the beginning of the summer, and tell yourself something 6 months ago, what would those two things be? Or those two people telling yourself at those two different time frames? So beginning of the summer and 6 months ago. You're muted, Paul.
Did you say in 6 months later or 6 months earlier?
So if you could tell yourself 6 months ago something now.
Oh. That's easy.
A few minutes. And for this one, I figure, well, if you want to share, great, but you don't feel like you have to. Well, is that enough time for everybody? Okay. Well, I can start. If I could tell myself something at the beginning of the summer, I would have bought more coffee. I just ran out, and I thought I had another box in my cupboard up until earlier today. So I would have reminded myself that that was an empty box of coffee in my cupboard, not a filled box waiting to go next to the coffee maker. And 6 months ago, I think I would have told myself to take on a little less this last year. I think I got such a little thin this past few months. And those two things might be related. Out of coffee and stretched thin, I'm not sure.
No relationship there, huh?
None. Yeah. I plotted it. I did the t-test. No correlation. No pressure. Was there anyone else who would like to share what they would have told themselves?
I think Paul should, because he said it was easy. I'm still struggling. I want to go later.
So mine are totally related as well. So as a brief point of context, today is my last day with an affiliation at the University of Illinois. In a few hours, I will no longer be employed there. And so 6 months ago, what I would have told myself is that it will all work out. And what I would have told myself at the beginning of the summer is you're going to need to spend some time retraining your brain to do real work instead of fighting for survival.
Everything will be okay in the end. If it's not okay, it's not the end.
I can go. 6 months ago, I think I would have said we were kind of juggling between two different testing methods, whether we were going to use kind of going through doors and windows or whether we were going to proceed with trying to drill holes. I would have told myself, go with the drilled taps, exclamation point, 6 months ago, I think. So we would have had that in order. At the beginning of the summer, I think I would have told myself to enjoy the sun. I didn't know it rained as much. Maybe this is an outlier this year, but I'd never seen it rain this much here. So enjoy the sun while it's there.
It doesn't. So I guess I can go. I don't know what to tell myself 6 months ago because I go through teaching and it just like kills me. So I throw up my hands, and 6 months ago I'd be like, "Damn it, you're going to do it again." At the beginning of the summer, I would have said, "Get on the river." I'm just like still fearful of going on the river, but I really want to. And the season is so darn short, and as you can see, the river's dropped a lot in the last week. I was lucky that I did something last Sunday, but I just don't enjoy it enough. I let work take precedence, and I don't get out as much as I should because I have lots of.
I can go next. So 6 months ago, I would have said to myself, you really should read that book the dean gave you about being an administrator, how to survive it. Because I didn't read the book. and I started reading it again about a month ago. I read and was like, oh, I should have read this earlier because I wouldn't have done the stupid things I did. Because yeah, it's right there in black and white. So that's what I would have told myself 6 months ago. That would have made things better in the spring semester for me, I think. And beginning of summer, if I'd read the book 6 months ago, then I would be telling myself at the beginning of the summer, probably just make some decisions and it'll be okay and you'll survive. That you're second guessing yourself too much with some of these administrative steps. So it all starts with read the book.
I like that. I can go next. I don't know if I have anything too profound. I guess 6 months ago, I would have told myself to stop procrastinating on wedding planning because now it's, 2 months away and I feel the crunch of, everything we have left. And related to that, in the beginning of the summer, I would have told myself not to wear my watch when I go outside because now I have this terrible tan line that I cannot get rid of no matter how hard I try.
Am I who's left? I think. The beginning of the summer. I don't know. I really don't know what I would say at the beginning of the summer. Maybe 6 months ago. I might have encouraged myself to state my goals for the teaching semester. I think I had goals around what to change, but not why I was changing them. So I think it kind of unraveled a bit at the end. Be better to have started with where I wanted to be.
Thanks everyone for sharing. I find it really, when I was thinking about this one, it changed over the last 3 hours after I thought about the question. So I'll think about it again for the rest of the day. I don't know if that means there's a lot of things I should have been telling myself, or none of the things that I missed telling myself were really that important. Anyway. Thanks everyone for sharing.
I think it's up to me to present. Tammy, you mentioned you had downloaded it. Would you still like me to share it, or?
Oh yeah, I am joining by phone right now, so I'm not going to be able to do the sharing. Allison's doing the kind of running. It's up to you.
Awesome.
But I do have a copy, so I can.
Right. If I can get the permissions, I may be able to share it myself. Oh, there we go. Okay. Right. See that all right? Awesome. All right, well, today I just wanted to present a little bit of what me and Tammy have been working on and some of the data that we've been collecting. So that is do a little bit of background, a little bit of refresher, the first couple slides. So why are we interested about pressure? We know that air flows from high to low pressure. And when we're dealing with residences, when we have gaps in the walls, ceilings, whatever, that's where we get our flow in and out, both air and pollutants. We also know that the three main forces causing this pressure differential across the building have to do with temperature, wind, and then mechanical ventilation. So for our measurements, we started out just gathering characteristics about the building. So Site 101 is actually Tammy's house. Spoiler alert. So we gathered some of the square footage, some of the leakage characteristics. And then for our continuous measurement, we used a weather station to gather outdoor data, a thermistor to gather indoor, specifically temperature data. And then we used a manometer, 3 manometers actually, to measure the pressure difference across the wall at 3 different points in the home. And to get across the wall, we had used a process of passing the tubing through windows and doors, and then kind of sealing up the rest of the door and window with masking tape. So a little bit more about this actual site itself. Tammy's house is a 3-story townhouse. There's 2 exterior walls, front and back, and the front one opens into a field, open field, and the back opens onto an alley. So it's important to keep in mind as we look at some of the data that we will. All right. So the data that we've collected actually has been over around 7 months. And so throughout that time, we've been able to collect a really large and pretty granular data set. I believe at the moment, I think it's just over 265,000 observations, and that's at the minute by minute resolution. So really, really fine granular data, which is great when we're looking at pressures, and something that isn't too common much, or at least isn't shown too much in the literature. While we haven't got the full taste of kind of summer conditions, we have been able to see some seasonal variability that we expected to see, and we'll touch on that in the next coming slides. So the first piece we want to touch on is stack effect. So this is the effect caused by the temperature difference across the walls. So first we'll look at what we call the winter condition, or basically when outside is colder than inside. This characteristic causes the stack effect, which we see in the winter conditions to be larger. If you think about it, when you are under winter conditions, generally the difference between the temperatures indoor and out are greater. You can have anything from 30 to 60 or 70 degrees Fahrenheit difference between inside and out. So we anticipated at least seeing that the stack effect would be greater. And also because of that, we also see the prediction method is a little bit better and more suited towards winter conditions. So we see in our graph over here, we have pretty good prediction. The blue, the blue is what was observed. So this is the difference between the manometers that were placed on the first floor of Tammy's house and the 3rd floor of Tammy's house. So this is what we were validating with. The red line is our prediction of it. So we see a pretty good tracking of the trends and magnitude also. We do see some spikes in the observed, which is likely due to wind, because we aren't quite able to extract that from the manometers themselves. But overall, really, really good predictive ability. Keep in mind, as we note here, that the average is probably just under 5 pascals. And so as we're anticipating that this is a larger effect in this winter season, we'll be able to compare that with the next graph that you'll see, and see whether our anticipated effect is correct. So now looking at a little bit of warmer climate. So this is May to June. Again, like I said, not quite peak summer conditions, but definitely very different than what we witnessed in January and February. We do see decently good tracking along this graph between our prediction and the observed. However, we do see, especially in kind of the troughs, which are nighttime predictions, they definitely drift a little bit, and the prediction is not as good during this season. If we also look and remember, the winter conditions average stack pressure was around a little under 5 pascals, whereas this one is probably closer to 2.5. So what we anticipated in terms of the magnitude of the stack effect holds in this case. So this was really, really interesting data to look.
Can I just?
Yeah.
Yeah, I'm sorry. Finish your sentence, but I wanted to say something. Are you on the slide 8?
Yeah, you go
I
ahead.
wanted to say
Go ahead.
something when you're done there. Okay, so one thing to look at for people who are not used to thinking about the stack effect is we loosely call winter conditions inside is warmer than outside. And that's actually happening at night in the peaks. So even though it's warm during the day, we can still predict what happens with cooler temperatures outside in the peaks. But when you get to the troughs, which is, and you can see the red line dipping below 0, then you never see the measurements dip below 0. And the below 0 means that the whole effect reverses, as Dom showed. And we never, or very, very rarely see that that when outside is warmer, that it behaves as expected. So I think a thing to look at is the difference between what's above 0 and what's below 0.
Yep.
Is that okay, Dom?
Yeah, absolutely. Absolutely. And I think there's a little bit of touch on this right here in the next slide. This is just kind of a subset of that more summer condition, just about week-long example of it. But yeah, like you said, looking at that line that passes below 0, this graph is, sorry for anyone that it confuses, the red and blue are a little flipped here. So the red is what was observed by the manometer, and the blue is what we predicted. So yes, as Amy was saying, the prediction generally stays up. Oh, yeah, Allison.
Muted. Sorry. I didn't mean to interrupt you mid-thought.
No worries.
I think a question I had was how you, like you're saying the stack effect is not well predicted. What are you using to determine like how well it's fit?
Yeah, I think the difference, but I don't have a graph for it in this presentation, but I did do a little graphing about the absolute value of each of the stack, both predicted and observed, and found the difference between those two. That was one way I looked at it. But I think generally visually, sometimes you can even tell the difference, especially in these nighttime conditions. So yeah, that was the two biggest things where I saw it.
And Ellison, maybe I could also add, eventually you might be looking for something like a mean squared error or a R squared or something, some quantitative error measurement. Right now, we're just looking at it qualitatively because, as you can see, so there's ragged nature, probably due to winds, but we don't know. We're not able to explain all the spikes, and those would really drive some of the error metrics. And so, so we don't have that quantitative error measure right now, but we do know that it's real.
Okay.
But
Well,
I think that the main thing to think about is that we don't capture the trough.
is that you don't have what? Sorry.
We don't capture the troughs here. That like between the peaks and the troughs, the peaks are better between the prediction and the observation, and
Yeah.
so there's something else going on
Okay. Yeah, I think I was looking for that, yeah, that kind of just qualitatively, because I don't look at these kinds of data almost ever. So, and goodness of fit really depends on what you're looking at. Because I look at them like, oh wow, your blue line is following your red line really well.
Yeah.
It's never offset, it doesn't cross it. Like so I'm just trying to see what your eyes see, and yeah, maybe quantitative measures would follow, but those probably would also have to be things I'd ask, like, well, how do you put that in context with what other people see in the literature or what you expect? But it's just helpful to know how you're looking at these data. So thanks for
Yeah.
the question.
Absolutely. Absolutely.
So Dom, can I ask a question here?
Absolutely.
So when you were showing the winter time, the numbers were positive. They're above zero.
Correct.
And they are still above zero here. Now, the theory is that it's going in the opposite direction. And so if it was, say, the measurement on the third floor minus the measurement on the first floor, then you would have positive numbers in the winter, negative numbers in the summer. Have you flipped which one is reference?
That is something that we have talked about I believe in our setup. I think we have kept it standardized in terms of we generally have the outdoor one running to input, and it's input minus reference. So I believe we've kept that standard.
So, hold on. So on each manometer, you usually do it inside minus outside. But then when you're doing the stack pressure here, that is it's a difference of differences. It's each one of those pressures is a pressure difference. And then the
Right.
stack pressure is the difference between two pressure differences. And so
Right.
in order to keep everything positive, have you swapped which one is which one you're subtracting from the other? And this looks to me like you're doing first floor minus upstairs.
Mm-hmm. Yeah, that
So
may have
can
been
I,
the case. Tammy might know better.
well, I want to clear some stuff up here. There's two things to clear up. One is that I'm afraid I've swapped the labels on what's projected versus observed, and that's caused by me trying to match what Don was doing, and I just did it wrong. And so my apologies for that. But to answer your question, Paul, I think your question is something like, hey, it's positive when you're talking about summer conditions. I think we could be more precise with our use of these terms. So between us, Dom and I have been saying it's winter conditions if it's colder outside, even if it's summer and it's at night. And so what you're seeing when the stack pressure is positive, is that it still is colder outside. What we're pointing out about summer conditions is that it should go negative, and so if you're looking at the graph that goes April 30 to May 5th, I've mislabeled those, but the observations are the blue ones, and the predictions are the red ones. And the prediction should go negative when it is warmer outside. And so the summer conditions would only be everything below zero. So the direction of the pressure measurement is identical for all the graphs. I don't know if that helps.
That clears it up for me. Thank you.
Yeah, so maybe we should, on this graph, put like winter on the top above zero and summer below.
Okay.
It's a shorthand that isn't helping us right at this moment.
Right. Okay, so another thing in terms of mysteries that we've been touching on, when we first started doing these predictions, we began by using everything that was collected from the weather station, the thermistor and everything. But instead of taking the density at the location that we were measuring at, we just used the density of air at sea level. So that's the graph that you actually see on the right, which we see, I mean, like Ellison was saying, that it's not quite quantitative, but even with the naked eye, you can see that the prediction is really spot on right here, other than a couple blips where the wind spikes, but really good prediction. And when we switched over to using the local density of air that was actually measured by the weather station, we saw a disagreement with at least more of a disagreement than what we had seen with sea level. So we honestly don't quite have an answer for this yet. We kind of played with the idea that maybe the manometer had somewhat drifted. But yeah, like I said, we don't quite understand why this kind of separation occurred. And so this, yeah, a mystery that we are still kind of evaluating and going through analysis for.
Naive question here.
Mm-hmm.
Does that happen to be anything related to like how something gets calculated? Is it getting calculated with the sea level pressure somewhere else, so that by using sea level, you're coming into more agreement? I don't really know. Only.
Yeah, I'm not sure. I'm not sure I understand the question. Sorry.
Yeah, I'm not sure I have a good question there. Let's leave it.
Okay.
It's a question that we've also had, Ellis. And so I think the next step is to try to find something against which we can calibrate the manometer that we know is absolute, and see if it's actually reading something different than what we.
Okay.
Because it just seems really weird, right? Like that it works
Yeah.
perfectly when we use sea level.
Well, yeah, it's making me think like,
very
oh, something was
sad.
in agreement with sea level already, and you just didn't know it, and now you
Right,
brought it into
exactly.
agreement.
Yeah.
Mm-hmm.
Yeah, but it's deep in the mysterious bowels of the instrument.
Right. Yeah, still mysterious.
Yeah, very mysterious. So Tammy, I don't know if you wanted to explain this one a little bit more. I kind of get the gist, but
Yeah, I can talk a little bit about wind, and so wind. What I'm showing over on the right is just how to think about what pressures you should be seeing with wind. So if the wind is impinging on the one face of the building, then it's going to create a positive pressure, and you can calculate what that pressure might be with Bernoulli's law. But actually, on different faces of the building, there are going to be typically negative pressures, and so the pressure actually from one face to the other is not exactly Bernoulli's law. So never. Let's see. So another thing to think about is if the wind switches direction, then those pressures are going to flip. Right now, I'm not very far into looking at the wind speeds. One thing you can certainly notice on this graph, say around April 20th or 21st, is that the pressure from front to back does kind of go with the wind speed. And then sometimes it doesn't. So if you look at April 21st and 22nd, those pressures are not going with the wind speed. So that's something we have to sort out. What we do see is that when wind speed is relatively high, it does create an effect, and then there's other things going on that are not necessarily seen. We do on occasion see that the predicted pressure and the measured pressure have opposite signs, and that tends to be when the wind is coming from the other side. So we have a cosine of direction shown in some kind of ragged yellow because of direction, so we can see that wind direction. But the implication of this is I don't think we're going to be able to predict wind as well as we can predict stack. And then we have to sort out what that means for the project, right? For our ability to infer what kind of flows are going to happen, and also what kind of pressures are going to be needed to counteract outside wind and for that smoke.
yeah. And
So
so,
I
yeah.
don't ever expect this to be perfect.
Mhm. Yeah, and this is something that we might need to do more analysis on, but it could be a function of both the way that we've been measuring the wind and how it's been collected, but also could have just been partially due to the way that the house is set up. I know we touched on kind of only 2 exterior faces, and so when you have winds coming from certain ways, we only have the weather station on one side of the building. And that could have be another thing that's having an effect on the way that we're able to predict. Another thing that we were able to see that was really heartening, at least, was that we see, this is just maybe a week, not quite a week long stretch, but we see kind of the probably daily troughs and peaks that we would naturally see, but we see these little undulations in there. And we were curious about that, and we ended up finding that this was the kind of makeup air scheme. So the air handler and the recirculation of the air throughout. We thought it was actually pressurizing the house. So it meant that the makeup air was taking air from outside in concert with the recirculation of the air already in the home. And by pulling that in, it was actually pressurizing the house, which it seems simple, but it kind of confirms what we thought and what Paul is will ultimately be working on in his mitigation system somewhat, in that we can use it to pressurize it and keep a pressure difference across that wall using it. So the last thing, this was actually done in concert with Paul and Will Claggett. We ran a blower door test at Tammy's house to try and see how well our tape sealant was operating when we were doing our measurements and how close it was to normal operation. And so we ran it. We saw an actual 11% increase in the leakage area, which honestly was less than I expected, given the nature, kind of the newer nature and the tightness of the home that we kind of had noticed and seen. But kind of this in combination with kind of concerns over thermal comfortability, energy efficiency, and then just kind of overall home kind of safety, we decided to move away from using the kind of door and windows with the tape sealant and move towards using drilled tap hole, which kind of is a callback to my getting to know you this morning. But yeah, so we're moving towards that and kind of currently underway at Tammy's house. Yeah. So moving forward, like I said, with the wind data and everything else, there's a lot of further exploration we still have to do with the Site 101 data. But we also are looking forward to moving into Site 102, hopefully within the next week. And once we have about a month-long sample there, we will be able to go into our Hopic Homes integration, and we may be able to do a couple of them alongside Site 102, but that's kind of the ultimate goal. Does anyone have any questions? Awesome. Okay.
Well, I'll make a quick comment. It's not really a question, but a comment, which is, on the wind data. Yeah, I've had projects where I've collected a whole lot of this sort of thing. And in fact, I had a project one time where I was like, I'm going to measure on both sides of the house to capture something about wind. And I had just a weather station on one side, just like you're talking about, of each house. And a colleague of mine said, why are you doing this? That's not going to be useful. And then after I started collecting the data, he looked at it, he said, well, actually, that is very useful. And it's not useful so much from a quantitative perspective, but more from a qualitative perspective. And so I actually when you're presenting those data, I realize that one of the things we want to be able to move toward is use that to predict what kind of maybe change in flow we might need to maintain pressurization. But I really think that you've got some really good data there, and there might be some big uncertainties in quantitative outcomes, but it's really consistent with what I've seen. And yeah, the directionality is big. If it's blowing on the weather station, that's one thing. If it's being sheltered because it's blowing from a different direction, then you don't see it as much, even though it's there. So I wouldn't in any way minimize the importance or value of collecting it, even if we can't get as precise predictions as we can with the stack.
I agree. Yeah. So we're really excited to further analyze that data, but thank you for letting me and Tammy share it with you.
So
Oh, sorry, go ahead.
well, I wanted to address your question, Allison, or your question a while back. So I think you asked something like, how does this agreement compare what other people have done? So far, we haven't seen any pressure measurements across envelopes like this. And so a lot of people have looked at flows or air change rates as a function of temperature difference in wind speed, but the intermediate point is pressure, and we haven't seen that measured. And we could be missing something, so please bring it to our attention if you do see it. The other thing is when these models were developed, there were very few measurements of weather conditions, and so they typically tried to scale wind speed data from the airport, and right, even the direction is not the same, but that was a major cause of uncertainty in the model. And so now that there are cheap and easy ways to measure weather data at the site, I feel like it's a really good opportunity to try to confirm or deny some of the models now that we no longer have that intermediate step of just not knowing how close the site can be.
Yeah, that's both of those comments are helpful. I think I remember in the proposal that you wrote that there were not measurements like these. I probably should have remembered, but did not.
I could always be wrong about that.
Increasingly harder to know.
That's kind of all I've got. I know if there's anyone else that had anything they wanted to touch on or had any more further questions or anything, more than happy to.
I had one question that's related to integration with Next Homes, but it's not about pressure measurements. So
Yeah, go ahead.
Since our IRB protocol was approved or really exempt, the flyer that we created or that you and Taylor and Tammy worked on, that's ready to go, right?
I believe so. I haven't seen anything that is necessarily holding us back. Tammy may know better. But yeah, as far as I know, I did hear that it was.
I should look at it again just because I did it with a temporary nature in mind, and so it's always dangerous to then send that forward to final. So I can do that shortly.
Okay. The reason I ask is because we're sending out our sort of final emails to Epic Homes households that we've talked about this before. We're closing out of the past study and we want to bring that to closure. We want them to know that's done. But almost all of those exit interviews have involved a question around, can we reach out to you about this next study? And I think with the exception of one household out of the 14, we're at least that have their permission to contact them. And so we're sending them a final report as well. And it seemed like an opportune time to say, and here's a flyer about the next study, because they were interested. They're like, I'd like to see more information. So we'd like to send those out by like the end of next week or the week after. And if that timeline's too tight for you all, I'm happy to pull up the flyer and maybe do some tweaking it at your direction, or anyway, I don't know
I'm
how
pretty
much.
sure it could go out. Yeah, I'm pretty sure it could go out. I just want to
As-
make sure that I didn't
Okay.
leave any hanging things like fill in this year.
Yeah, right. Okay, so that was my thinking. If it was minor things, then maybe in a week and a half, that we could just attach that to that email. And again, it's not, it's just helping us sort of keep the communication going, and keep getting the soft yeses until you're ready for us to like actually consent someone into the study.
No, I think we could be ready. And I don't think anything will happen before the holidays over, right?
Okay,
So
yeah,
it could be done shortly after that.
okay. Thank you.
We're talking about minutes, not weeks. Anyone else? that they wanna ask?
I don't know if I have the authority to call this meeting to adjournment, but if anyone doesn't have anything, I'm sure we can have your last 15 minutes back. But
Yeah, I don't
thank
have
you.
any further questions, but I do appreciate you fielding the ones I did have and presenting what you've worked on.
Yeah, thanks, Don. That was interesting.
Thank you. All right.
I-
Well, thank you
Tammy,
all.
we'll adjourn. Is that okay? All right, this recording will go to the cloud.
Awesome.
See you guys.
Thank you.
Yep, have a good
Thanks.
weekend all. Bye.
Thank you.